Hello, today we will solve GATE 2020 question number 32 from Mechanical Engineering Set 1 paper. The question is, a strip of thickness of 40 mm is to be rolled to a thickness of 20 mm using a 2-high L having rolls of diameter 200 mm. We need to calculate the coefficient of friction and arc length in mm. To solve this question, one can refer to the NPTEL course video lecture which is mentioned over the right top corner. So first we need to understand that what is the rolling process. So rolling process is basically one of the metal forming process in which a stock of material is passed between one or more pairs of rolls in order to reduce and to maintain the uniform thickness. Suppose we have a material like this with some thickness T and having a very long length L, and we want to reduce this thickness T to some T dash. So what we will do, we will just pass this material between these two rolls, or we can say the multiple pair of rolls, such that it will apply pressure on this workpiece and will reduce the thickness. So we will get the final thickness as T dash. This is T. So here T dash is less than T. Now there are two kind of rolling process. So rolling process, the first one is hot rolling and next one is cold rolling. In hot rolling process, the material is deformed above the recrystallization temperature. This is above recrystallization temperature, and in cold rolling process the material is deformed below the recrystallization temperature. Now we will try to understand that the mechanism of this rolling process. So let me draw two rolls first. So this is the roll 1, this is the roll 2. Now I am passing the material of thickness H and I am getting the thickness H dash. Now the contact which is making the workpiece, the roll is making with the workpiece is this much. This is the contact zone which is making an angle theta. Now what happens in rolling, if you go with the microstructure or grain, the original materials is having the larger grain size here like this. When it passes through this through between these rolls apply the pressure on the workpiece and this grain gets elongated. So in this zone the grains will be elongated. After a certain distance there is two possibility. If this is a hot rolling, the after this zone, after certain distance, this grains will this girl will start refining. That means we will be having some small grain size here, which is refined. This is the case in hot rolling. Now if we are doing the cold rolling process, it will just try to the grain will try to retain the shape as it is having earlier. Now what we understand from this point is, in hot rolling, the refinement in hot rolling, we observe refinement of grains, but in cold rolling we don't observe such kind of refinement. Now we will jump into the mechanics of rolling part. So mechanics of rolling, and we will derive the expression for the length of contact and the coefficient of friction. So let us draw the two rolls first. So this is the roll 1 and this is the roll 2 with the centers O and O dash. Now I am joining with these two center with a vertical axis. The material is passing between these two rolls and coming out of this right hand side direction. So direction will be from left to right. Now this is the contact angle by which is called right angle theta. This is the length of contact, which is O A. This is B, and this is delta H by 2 because this is H and this is H dash. Delta H will be H minus H dash, and this will be delta H by 2. Now A to B is length of contact, which is denoted by L. Now this is the contact zone here, which is also called the pressure zone, and there is one neutral point here, neutral plane, we can say. It is a neutral plane. Suppose this is the velocity v1, the velocity of the material, original material, and after deformation the velocity of this material on the right hand side is v2. So in neutral plane the v1 is equal to v2. Now we will derive the expression for the length of contact. So from geometry, if we apply the Pythagoras theorem to this triangle OAB, then we will get L square plus r minus delta h by 2 whole square is equal to r square. This implies if we open the bracket, L square plus r square plus delta h by 4 delta h square by 4 minus r delta h is equal to r square. Now here delta h is very small than r if we compare delta h and r, and also delta h square will become very small and it can be neglected. So this term is neglected here, and we get L square minus r delta h is equal to 0. So L equals to under root r delta h. So this is the expression for the length of contact. Now for the self entry, we must have the coefficient of friction must be greater than or equal to tan theta. Now what is tan theta here? Let's see this triangle here again. So I am drawing this triangle again, this first roll. So this is the first roll, this is the center, this is L, this is R, O, A, B. So here this is the tan theta, which is called bite angle. So what is tan theta here? Tan theta equals to L divided by this OB. So OB is nothing but this is R minus delta H by 2. So this is L divided by R minus delta H by 2. So we have derived L is equal to R under root R delta H. So we will put here tan theta equals to R delta H divided by R minus delta H by 2. But delta H is very small than R, so we can neglect the delta H by 2 term. So we get tan theta equals to delta H by R whole under root. Now to satisfy the minimum condition, the minimum coefficient of friction must be equal to this value delta H by R under root. So from here we get delta H equal to mu square R. So this is the first expression we get. This is the second. Now we will solve the main question. Now what is the given data here? We have been given the H naught is 40 mm, H final is 20 mm. So we can get from here is delta H. Delta H is 20 mm. Now the diameter of rule is 200 mm. So here R will become 100 mm. Now we have to calculate the projected length. So L is equal to under root R delta H. This is equal to under root 100 multiplied by 20, which is 2000, that is equal to 44.7213 mm. Now to calculate the coefficient of friction, we will use the second formula. So mu square is equal to delta h by r. So delta h is 20 and r is 100. So mu equals to 0.4472. So the answer is 44.7213 and 0.4472. So answer is D.